Okay, more people is arriving. Welcome, people. Welcome, Seba, Lucas, Gonza.
Yeah, hi, how are you?
Hi, guys.
Hello. Thank you for your assistance.
Sure.
Oh, thank you.
I know.
Hi guys. Kubernetes is in my pending list, so
Hey, Seba.
I did too. Hi, Fabri.
Guys,
Okay,
I
so
don't know if you can see that, but Rafa posted a link on the Zoom chat. If you open that part of the UI, you will see the link, which is to some questions. A way
Oh
to
yeah,
ask him.
about the background, right?
Yeah.
Yeah.
you can just.
I think I filled the form.
No, not the background, but there is one more with a question deck.
Yeah, there is a on top. I don't know if you can see. I'll share this link in the chat, in the Zoom chat. Give me a second. It's basically you can do questions there while the
Nice.
presentation is happening, or prior to that, or after that, afterwards. So there you go. Also, just to make the presentation straightforward, can you please mute your microphone whenever you're talking or during the presentation, so nobody will have the noise in the background.
We'll do that now.
Right. Thank you. So this is the time. Basically, we have sensors and seven. Okay, have new one, Diego. Welcome, Diego. I will start, and if anybody joins, can you help me with the chat? Just telling the guys about the ask a question. Just keeping the microphone off. That's it. Okay. First, thank you guys for coming in. I'm Rafael Aguilar. I've been working with software engineering in general aspects for the past 10 years. And I have the nice opportunity to work with this amazing team, Whiteprom. And right now, I just going to give you an introduction to Kubernetes as one of the tools we have out there to bring better value as a software. Actually, what is more catchy to say, a tool which is very useful for software delivery. So there is a good question that Fabricio asked. Why Kubernetes? Kubernetes is the Greek word, or came from a Greek word, and basically means like the one who is piloting a ship, or the one who is leading in the middle of tempest, as the name of the presentation says. What Kubernetes will help us is just to try to get through different problems, different difficulties we have when delivering software as a value, either to the world through the internet for a specific consumers, or even internally in our enterprise, or whatever place we are working on. So first, I'm going to do some background. Just I can see that we have variety of in our audience or the experience, and I won't go too deep into this, but 10 years ago, over 20 years ago, software delivery was very, very different of what we are working currently. And we have major frameworks like ETL or RUB, which pointed to be a standard. The first one made it, the second one didn't, but gave us the awesome tool with UML. And in those scenarios, IT was a whole. Was thinking as a whole. We were thinking from the billing guy who need to sign off router purchase or disk purchase, and all the governance, the change management, everything was very specific. You can see where actually our Cisco distribution has people as an icon, because people was like in the middle of diagramming. And teams were very, very relevant for this kind of diagrams. So don't pay attention to diagrams. Just wanted to throw back something. This Thursday, just not throw back Thursday for 20 years. So this was made to comply with vertical organizations, which was very. You have like 10 people above you to make the decision. As I said, manage IT as a whole from within of the company instead of a specific values of specific domain areas. This brought different problems, like several areas working as a silos. So the billing people didn't actually matter because their goal was to get lower the billing, and the software people needed to push some changes, and the operational guys just wanted to work everything as it's working right now, even if it's buggy, but it's working. So these silos have had a lot of issues and delays, particularly delays to software delivery. I don't know if you didn't have that lucky to have push a change to your repo and haven't seen it in production like after 4 or 6 months. That was very usual back then. Actually, back then I said 1920 to early 2000 because that was where ITIL group was very, very hype. But actually, I worked in something like this like 8 years ago. We was following these methodologies. So just a sneak peek into ITIL change management process. You needed to basically the client has a requirement or an incident. Later, we needed to, after the analysis, of course, we needed to make a cost justification. You have to go to several manager reviews and later go to the IT, and T will say, we need this and we need that, we need this disk, we need a database. For example, we are going to deploy a new application or we need to solve an incident and we need to add more space to a table space or a database. And this might require a new disk or creating space for other things. And we needed to justify the cost. Actually saying why we need to invest this to solve that. Later getting approval of multiple managers, as I am telling, there was a famous change management committee or steering committee, which was probably all the people involved. If we needed to do a purchase, probably somebody from purchase inside of IT will come to this committee. If we needed to change something in the networking, we needed to invite somebody from networking. If we needed to have set up some virtual machine with some specifications, we need to buy the infrastructure team, and so on. So this steering committee was actually one of the barriers to get change getting on. After that, we get implementation, QA, documentation, and at the end goes to the client. So looking at this, it was normal to have a change, to have 1 month, 2 months, 3 months going to get actually into production. So I'm going to jump forward because this is an uninstructed class. And right now we're going to introduce you to declarative infrastructure who don't know it yet. So what are the benefits of it as well? So basically, infrastructure as code, this is not a fair comparison. Previous example was on-premise, and right now this can be on-premise, but also on cloud. And there is a 2-decade difference. So it's not a fair example, but I just wanted to overstate the relevance of the declarative infrastructure. So what we do with infrastructure as code is basically just creating agreements between all these areas, and instead of per change agreeing and negotiating all of these aspects, we can create actually a framework or limits or boundaries. I mean, networking guys can say, okay, in this small world or this subset of all of our resources, you will have these IP ranges, and you need to comply with everything as secure in transit and, for example. And you also need to only go to the internet using this gateway. You are coming through, traffic is incoming through this another gateway. And so it can allow us to just frame our work, our internal work. Also, we can say the same with budgeting. We can say the same with security. So what we are going to have is a state, and this state will change through the new changes, the new declarative changes. So what we're doing, we are basically describing what we have or what we want. And later on, we're pushing small changes or different changes that will alter the state of this state. And this is basically what we call infrastructure as code driver or controller. just to name a few. Terraform Kubernetes is one of them, CloudFormation for AWS, and so on. How this works? You just put in the new change, which is a yellowish box. I want a public IP, I want new volume and 2 nodes, and I can say specifically what kind of 2 node through text, plain text, and the same with the storage and network. We pass it on to the infrastructure as code driver. Actually, you can see this black, yellow, reddish box. This actually can be some agreement in the top, so we can fail earlier. Let's say this public IP, we need it to be within a range. If this public IP is not within that range, it will just fail before getting to apply it. The same with all the aspects of infrastructure. So the driver will calculate the differences between the current state and the described state, and will apply the differences. So we will have a final state. So in the new, as you can see here, previously we have only 1 node, and after checking the differences, we will have 1 volume, 1 public IP, 2 nodes. And the next iteration, basically this final state will become the current state. So what we have, embedded change management. We have early failures. We have native traceability regarding the features because it's code. We already know what Git, SVN, all the SVS, CVS allow us. Replicability. And one thing, replicability is very, very important, is when if you describe one environment and you want it in other place, if you already describe it, you are documenting it, but you are also describing the process. So creating a new environment, a clone environment of this will probably take just a few minutes or seconds, depending on the environment, of course, but it should be very, very, very similar. And also, and something that probably software engineers like, as this is plain text, this is code, you can also test code. So you can test your infrastructure even before it exists. And just a little bit about DevOps culture. People is the most relevant part for DevOps culture, the most relevant aspect of software delivery. And things that when we use a culture as a cement, as a foundation for delivering software through standardized processes, using technologies such as Kubernetes, we can deliver software with a reduced time to market, with a reduced time to recover after not only day 1, but day 2 operations, and actually more accurate total cost of ownership. As you are describing not only your software, but also your infrastructure, also your processes, you can make it more observable. But this isn't a DevOps culture talk. Maybe in the future we can have it. So right now, what we're going to see is how technology, which is Kubernetes, one of these technologies, can offer us different kind of abstraction, so we can create processes which has been basically pushed through thousands of coders that have put their knowledge into Kubernetes, using the DevOps culture to empower people to deliver software faster and with higher quality. So yeah, where is the Kubernetes stuff, right? So we are here for Kubernetes, and let's start with just very basic concept. We are going to go through basic concept of Kubernetes. This is a 101. This is just like, what can I do? A brief example of it. And we are going just to see the very basic elements of Kubernetes. And one of them is the pod. You can think of Kubernetes, and we will see at the end how everything is an abstraction, how we can abstract not only infrastructure, but we can abstract metrics, we can abstract software, we can abstract processes. And this is the most basic part. A pod is the most basic part of Kubernetes. I'm not going to discuss through the technology of what a container is. There are different engines, and Kubernetes can work on top of them. The most popular one is Docker, but you can also use Linux containers. So a pod, what actually is just a group of containers within one IP. So these containers will talk each other like they were a local host, and to the rest of the pods or the rest of the infrastructure will be basically just one pod. They won't talk directly to a container. through an IP given by the networking layer. Kubernetes, one of the aspects that abstract is the networking. So there are different kind of networking. We can see that in Kubernetes 2.1 later. But one of them is that basically Kubernetes assign IPs to these pods and manage these IPs. These are local IPs within the cluster. And as you can see at the left, and we will see the rest for the rest of the concepts, this is just simplistic code or configuration. This is a YAML in this case, which is saying which is the API we're using, which kind of resource is this, some metadata. This is very relevant about this specifically, the app, my app. We later can say which kind of containers. Basically, we can have multiple containers, not because they will live all together, but we can also have initializers. For example, we can create one pod, but one container that will have, I don't know, so many checks, different checks or different, will create some information that the next container will use. But this case, we will have only a couple of containers running inside of a pod. Later, we have services. Services is the way of how my pod, which has only one fixed IP and a particular DNS name, will be accessed again in a new level of abstraction by other inside of our cluster. So while a service is just saying, hey, I am just declaring a service. The name of the service is backend. The selector is, okay, after something, after the request came to the service, where should be redirected, where should be routed. So we are saying, okay, whatever has a label called app with the value of my app will be routed to. If you check here, it matches with this. And we'll say, okay, and you will be exposed through which port. And say, okay, you will be exposed port 80, but the target port where you are going to forward the traffic is for 8080, which in my previous description was 8080. We have also deployment. In this case, I'm going to do a deeper example of what a deployment is. Deployment first, you're basically describing instead of the pod for each pod, instead of describing, I want this pod in the service in this particular namespace. We're going to see what is namespace later. We can describe what a deployment is. And in this case, we are going to go just a little bit deeper. Is a replica set. There are different kind of deployment. A replica set, and this actually should be. I haven't updated this from the previous presentation, but you can think of a replica set. You're saying, hey, this is the template of the pods that I want. So this is exactly as we was seen before, but as a template. And we're saying, hey, I want two replicas. These are the match layer, the selectors. We are already familiar with this concept. It helps us. It's very, very useful for self-healing. What happened if one pod just goes down because the container crashed? If the container crashed, stop existing, the pod will be eliminated and will be not working. But if we are inside of a replica set, this replica set, through a Kubernetes objects that we will see later, it will be observing and watching this replica set. And if something goes wrong with one of them, it will bring up another one. So we will have self-healing natively. We can also say, hey, instead of two replicas, we want three, and just changing this parameter, Kubernetes will say, okay, let's have another pod. There is very interesting things that we can do with this, because we can plug it into our auto-scaling metrics. And so there is another concept we will see in other talks regarding Kubernetes, which is horizontal pod escalator, auto-scaling. So we can say, hey guys, when these metrics enter this threshold, just go up or go down. This can be as simple as a request per second, or this can be as a load of the container, or this can be a much higher level. For example, this is amount of active user at the moment. This is we are getting down our conversion rate. So we can have, because all of them are metrics, again, Kubernetes, everything is abstracted. So whatever metric we can plug it into, change a scale out or scale in is very, very easy. You just need to change this. You or an automated process. Sorry, I don't checking the answers, the question right now, but let me see if somebody has any questions so far. Okay, Harish is the novel one only by now. So this is everything great, but we were talking inside of our Kubernetes. While through a service, I can say, hey, this is a local service, and this can be exposed to just a cluster IP. The Kubernetes will assign IP for the service. We can also assign a node. We will see what is the node in this case. It's not relevant now. Or we can say, hey, this is a public service, and take this load balancer. This service will be a load balancer, and it will be exposed to publicly, whatever we call publicly, either some network outside our team or internet. And what is happening in the background, I will explain just a couple of slides later. So what is an ingress is? Well, a service is capturing the traffic and routing it to the pods we were doing with the selectors. An ingress can do the same, but for different services. And actually, it's on top of, you can see as another abstraction on top of services. So in an ingress, you can do layer 7 operations, and say, in this very simplistic example, we say a subdomain, and this is taken from HA proxy if somebody has used it, and please redirect it to the service backend. And the ingress can have multiple roles, so it can be on front of multiple services. And this is very simplistic. This is the host. It shouldn't be a path, but the host itself, and go to backend and go routed to this port, which matches with what we have seen before. There is a couple of bugs in this description, I will say later. So checking all together, this is still ethereal. We are discussing about abstract things. We were going to see in next slide what the physical aspects are, but putting all together, we can, to the internet, to our outer network, we can go through an API example.org. This will be managed through a DNS somehow pointed into our ingress, which will have a public IP. It will take the subdomain, and the IP will route this traffic to the backend service. The backend service, and with this IP, with the cluster IP, this is the way the square, green square represents. And there is no standard for this. This is just something I used to. And the service will later route the traffic for the actual pod. We'll compute, and our software is deployed, and we'll have this information and we'll bring it back. But I will present another concept, just the surface, which is stateful set. While the replica sets are awesome for stateless, because it will require new pods on demand, or we'll drop them, a stateful set is much better, or is actually the fit for stateful services. For example, a database. We will have our pod, we will have here our application, and this application needs to communicate with database. So we can configure the pod to communicate with database, and that's it, database service. I don't care the IP, I don't care anything else. It's the database inside our namespace. So this blue square you can see here is our namespace. And what namespace is, the best way to think about namespace is just a subcluster. We have a full cluster, which is Kubernetes, and we can subdivide it by namespaces. And namespace has a lot of good features. We can apply policies at namespace level, resource quotas at namespace level, different kind of thing. But going back to our example, the pod will require, hey, ask to database something. You start to think that the configuration for the database URL is very simplistic. This database will have, for example, a load balancer, or layer 4 load balancer, that the red square represents, and will redirect to the actual pod. As you can see here, this is the same pod, but different replicas. So pod X1, pod X2. In this case, our stateful set can be 2 different pods, completely different pods, and I can say actually how they will bring in, how will they come alive, or how they will go down in a specific order. And this is very very simple way to do it. We can have the query manager here, and we can have the actually resolver for the data here. So we can have a cache layer and the query solver just computing. No, not necessarily we need to have a volume for this, but where the actual data relies, where actually is a stateful service, it can have in another pod. So when at the service layer or monitoring layer, I will be monitoring just the service. Service is up and healthy, and the backend is up and healthy. And our engineers will be taking care of that this is working because in the previous scenarios we also have described yet. And we can have, in each of these squares, you can have different kind of monitoring tools and metrics. So this is not Kubernetes YAML, but in the aspect of a declarative way, you can see we have one namespace, which has one replica set, using one service with a layer 7 load balancer. And in this case, behind an ingress, which is here, it has only one rule. And we have a stateful set, which have one service with a layer 7 or layer 4 load balancer. We have one pod of one, I mean, of the type 1, and we have one pod of the type 2. Each of these pods, the first one has 2 containers and 1 IP, and the second one has 2 containers, 1 IP, and 2 volumes. Maybe 1 per each container, we don't know. We still have some time. I want to explain this. This is very, very, very awesome feature about Kubernetes. It will compose and will create in the network abstraction that we can see later, that we can see in future talks. It will compose basically a DNS name that can be resolvable in any place of the cluster, even if it's a multi-cloud cluster. You can just say which is the service. This service, this DNS will be created inside of our namespace. So if you are inside of this namespace, you can call backend, and that's it. It will be resolved with this IP. But if you are outside of our namespace, you can specify the rest, like namespace. You can say namespace, and you can say what kind of resource are you accessing to. So this is the service backend in the test namespace, and in which cluster, of course. In this case, we're just describing one cluster setup, which is easier. We can later, if somebody likes to, we can go over a multi-cloud or multi-cluster setup. And just to check on a bit and get our fingers a little bit deeper, while Kubernetes works. So basically, Kubernetes is just knowledge as a platform. There's a lot of people doing software delivery, as we've seen in the first slide, and they just realized that there was a lot of things that, with agreements and with set boundaries, external boundaries, we can put a lot of this recurrent process as software. So what is Kubernetes? Kubernetes is just these guys. You can see it here. etcd is a way to store a server to store configuration. It's a key value database. We have a controller manager. Basically, everything is managed. Each resource is managed by a controller. So we have a controller replica set. We have controller ingress. We have controller for everything we have in our cluster. We have an API server, which is actually the entrance. So we will require new resources. We will describe which is the state of our cluster. And we have a scheduler. The scheduler is, for example, if we require a new pod or we require a new replica set to scale 10 times, the API server will update etcd, and etcd will have webhooks and will say to the controller manager, hey, this is the new configuration. The controller manager will check the differences and will answer back, or can ask the scheduler, hey, I need 8 new pods with this description. If the nodes, which are basically just virtual machines, or it doesn't have to be a virtual machine, it can be a breadbone, it can be a Raspberry, it can be your cell phone, or even your laptop, with these couple of guys, which will convert whatever of these resources into a Kubernetes node. And it can require also to our backend information, infrastructure backend. And when I say infrastructure backend, the most known one is cloud, but you can also have behind of it VMware. You can have behind of it Proxmox. You can have a human, and actually the scheduler is opening a ticket and, hey, I need a new virtual machine, or I need a new disk. So the scheduler will try to create whatever is needed by the controller manager, set it up, and later, if we need to set the new pods, this can scale out this. And there's one important, as you can see here, sorry, okay. As you can see, this reddish line is that this is our replica set, and this our stateful set. And what I'm saying here is, as you abstract, everything is an abstraction of it. You don't need to worry where is it. If you like to then to be in the same node because latency or whatever need you need, you can specify through metadata, hey, this need to be together, or this cannot be together. That's also another thing. So you will have resiliency. For example, if you scale out three replicas and you want to say, I want this in each in one node or each in one availability zone or a failure domain, Kubernetes will take care for you with using the right driver. So what is the advantages at the bottom line of Kubernetes? We will have a greater adaptability. So we can change our infrastructure state at any given moment. We have easier security governance because we can have put in this agreement, we can put a lot of tests which can actually enforce, like you cannot have a port with you can have a container running with root, or otherwise override this. If the container is running with root, you are going to override this using Kubernetes. You can set budget quotas as well. So the billing guy, you can agree instead of bit by bit what you want to spend. You can agree on a range. I want to spend $1,000 monthly. Okay, and this will be an agreement for our namespace. We can go over 2 virtual machines, or we cannot go over 100 pods, and so on. As you can see, as everything is natively observable, everything can be just plug in and say how many we have, how are they behaving, where are they at any given moment. We can scale to the need. This is actually a cloud vendor lockout, while you can be locking into Kubernetes. Right now, the major cloud platform offer a Kubernetes experience, a Kubernetes service, Google, Amazon, and Azure. Of course, all of them have their drivers. They actually, when the scheduler asks for a load balancer or asks for a node, they execute software, which is provided by these vendors, and will tell to their cloud, hey, I need a new virtual machine, just as we were doing through the UI. So we can, if we have our application abstract level enough, we can deploy in any of these major clouds, or even in all of them at the same time. Native replicability, I already said, just to replicate one environment is just to replicate one namespace. So if, for example, we can have different kind of abstraction, but I like the one-on-one comparison between namespaces environments. And there is a long list of etceteras I can go on, but my time is up. So I going to, if you have any questions. Okay, there is one from Fabricio. I don't know if you are seeing the second or the first, because my second screen just shut it down. So let's go with Fabricio. Does Kubernetes come with tools for monitoring included, or it needs to be configured as one of the services within the namespace? That's a very good question. Kubernetes itself has metrics, but for its own usage. For example, it will rely on whatever the technology is below of it. Kubernetes is just an abstraction on top of what is controlling the actual infrastructure. So if we're talking about Docker already provides for container management. Docker already provides, for example, the input-output operations. It will also for the networking, for compute, and if I'm not wrong, also for space. I'm missing one of the 4. So Kubernetes will take advantage of those metrics. If we are talking about Amazon, and when you provide a virtual machine, this virtual machine comes as well with these metrics, and Kubernetes can make use of them. But one of the tool set, which is very common to find in a Kubernetes setup, is Prometheus plus Grafana and Jaeger. And this is very, very easy to deploy into Kubernetes. Actually, is easier than deploying a Kubernetes cluster. And you will have natively requests per second per pod. You will have memory uses across your cluster nodes. You have a lot of log metrics. And even on top of that, if we use a mesh service, you will have a surprise of the things we can do. But I won't go there in this talk. There is a new question from Gonzalo. And Fabricio, just tell me if your question is being answered. If
Yeah,
not,
absolutely.
Okay.
Good answer, thanks.
When would you say it is time to switch something like Heroku to Kubernetes? Okay, I like Heroku because you can start right away. It's like you just try to type it. And I think that the time to switch is for an organization, not for a specific individual, but for an organization. When you want to go to Kubernetes, when Heroku, you start to get hit with the limits of Heroku, either by billing, which when you want to scale is kind of high, but also when you find yourself doing sort workarounds to deploy this in the Heroku way, or to deploy that in the Heroku way, or when you start to see the differences across the local environment and the product environment or the testing environment. One thing that I didn't mention is Kubernetes also brings different kind of distributions, and one of the subset of this distribution is local. You have micro Kubernetes. You have also, I forgot all of, I have used micro Kubernetes, but there are 3 or 4 of them which are very popular. I will invite you to, we are invited to a workshop of this talk. We can, if people is interested, if you are interested, we can go over and deploy a micro Kubernetes into our computer or into Raspberry, whatever you want, and deploy there a simple example. But
I'm interested on that.
The limit for me, not only for Heroku, for whatever platform, is when you are getting this is not fitting your need as with the software development lifecycle. And with Kubernetes, everything is an abstraction. For example, something like chaos engineering is very easy because you have a service which has a label. You can create any kind of labels there or pods, and later you can inject chaos, saying, please get delay networking response from any pod with these labels, and that's it. You don't need to specify anything else. You can say, bring down this namespace or bring down this stateful set. And that's it, because Kubernetes will try to get it up or get it down later. And these kind of things in other kind of platform, while there are solutions for this, Kubernetes, I think, is an awesome landscape to create plugins for these different kind of tools that helps to deliver better software. Is your question answered, Gonza?
Yes, thanks, Rafa.
Anybody else? Okay, I think, or either this has been very educative or something happened in the middle. I just wanted to thank you for your participation. Hope to see you at the next talk or either the workshop. You can, if you want, if you are interested in the workshop, you can contact Fabricio or me, and we will try to again schedule this.
I will